Okay, this is AMC 12 2004A, question number 17. I'm just choosing random questions to go through from past AMCs and to illustrate certain principles of problem solving. This one says, let f be a function with the following properties. Number one, f of 1 equals 1. Number two, f of 2 to the n equals n times f of n for any positive integer n. And ultimately, it wants to know what is the value of f of 2 to the 100. It's a pretty overwhelming question. At first, it feels like, how are we going to do this? We don't know what the function is. Typically in school math, when you're learning pre-cal or algebra 2 or whatnot, you know what the function you're working with is. And you just manipulate that function, or you work with an already manipulated function, and you tell something about it, like a graph or otherwise. The problem with this one is we don't know. And that often causes a level of panic in the problem solver. They feel like, oh, I can't do this. How can I do it if I don't know the function? All those feelings are normal. You have to get past that. And you have to latch on to is what I call the deserted island principle. The deserted island principle is as such. If you find yourself on a deserted island, are you just going to lay on the beach and write SOS and hope a plane flies over and sees you and you get rescued, right? No, you're not going to do that. I mean, yeah, you're going to write SOS, but the next thing you're going to do is you're going to start trying to find a way to sharpen a stick and go hunting. Or you're going to go look for roots and berries to eat so you can have sustenance. Or you're going to go look for fresh water. You need fire. You're probably going to bang two rocks together and hope a spark is created, right? You don't just lay there and wait to die. That's the point. You cannot just roll over for a problem like this. You have to make headway and see what happens, okay? So we want to see what happens in this problem. Where do we begin? Well, we begin with what we know. We know f of 1 equals 1. How can I use that in some way? We also see n times f of n. We probably should start by plugging in values for n. The logical value to plug in for n is 1 because we know what f of 1 is, and that would create an f of 1 here. So we start with let n equals 1. F of 2 will be equal to 1 times f of 1. F of 1 is 1. This is 1. We've now taken the given information and led to a second piece of information that we can build on. Do we know where we're going or what we're doing? No, we don't. That is a normal feeling in problem solving. You can't think that the good solvers know exactly what to do from beginning to end in a problem. It's more like you're exploring the problem and trying to find the solution path, which will be obscured from the start of the problem. Okay? So then we say, what's the next thing we want? Well, let's just try n equals 2. Why 2? It's the number after 1. We'll just march along and see what happens. If n is 2, we also know what f of 2 is now, which we're going to create when we plug 2 into n. So you're going to get f of 2 times 2, which is f of 4. That's going to equal 2 times f of 2. What's f of 2? It was 1. This is 2 times 1 is 2. So far, so good. We got a long ways to go to get to 2 to the 100. We should probably try to save some time. Why would we let n equal 3? If we do 2 times 3, is that a power of 2? It seems like we're looking for powers of 2. In fact, what we want is when n equals 2 to the 99, because you have 2 to the first times 2 to the 99. That's 2 to the 100, which is what we need to find. So the next logical thing to pick for n is let n equal 2 squared. We've already got, you consider 1 2 to the 0, right? So 2 to the 0, 2 to the first, 2 to the second. We're looking for a pattern. When that pattern emerges, we capitalize on it and find the answer. So we let n equal 2 squared. This will now say f of 8, 2 times 4. We can also say that's f of 2 cubed. And it's going to equal, again, n is 4. It's 4 times f of 4. And we just found f of 4. It is 2, so this is 8. Now, you cannot just see 8 and go, oh, that's the number after 7. That's a worthless way of thinking about it. We need to think about it in the context of the problem, and it seems that powers of 2 are important. You have to look at 8 and go, that's 2 cubed. So we write it as 2 to the third. Next up, we need to see a pattern. If we think of 1 as 2 to the 0, consistent with powers of 2 being an underlying principle of the problem or characteristic, we can see that from here to here, the base never changes, but the exponent goes from 0 to 1 and 1 to 3. Well, that's plus 1 plus 2. Looks like we're just adding to the exponent 1 number greater each time. We should see if the next one, to confirm our suspicion, is 2 to the 6th, which would be plus 3. So we look at f of 16. This occurs when n equals 8, which is 2 to the third. If n is 8, I get 8 times f of 8. 8 times f of 8 is 8 times 8, 64. That's 2 to the 6th. It's exactly what we suspected. Now we have to figure out what to do with it. You sense that you're close to the problem. You're a little bit probably past second base on the way to third base. Going to be rounding for home here soon. So what we need to do now is, how do we know where to stop? This is 1. You could say 1 equals 1. 3, it's plus 1 plus 2, so it's 1 plus 2 equals 3. Then we add 3. 1 plus 2 plus 3 equals 6. What are these numbers called? They have a name. They're called triangular numbers. They're called that for a reason I'm not going to go into right now. But the triangular numbers have a sum formula. It is, when you add to n, it's n times n plus 1 over 2. It's worthwhile to memorize this formula. It comes up a lot in the AMC. If you can't memorize it, you can just go to arithmetic series formula, which is the average of the first and last times the number of terms. So from here, we don't know how to quite use it yet. Where do we want to stop with this exponent? When we had 2 to the third, or when n was 2 squared, we added up to 3, which was a sum of 1 plus 2. How many numbers are there on the left? There are 2 numbers on the left when n is 2 squared. What about when n was 2 to the third? When n was 2 to the third, there were 3 numbers on the left of our equation here. Therefore, we want 2 to the 99. We're going to need to make n 99. We plug that in to get 99 times 100 over 2. 9900 over 2 is 4950. This is not the answer. This is the power of 2 that was there. It was 2 to the 6th, not 6, right? So then this is 2 to the 4950, which is answer choice D.